Next, half range expansions. Half range expansions. Question can be half range cosine series of, or half range sine series of, or just sine series of f of x that is defined in half interval 0 less than x less than p. This is half range expansion. The given function, you see the given function, its domain will be from 0 to p, not from minus p to p. It's only half of minus p to p. From minus p to p we have total length 2p, but from 0 to p it is only half length, p length. It is half domain, or domain is from 0 to p. Then the expansion is called half range expansion. This half range expansion can be either cosine series or sine series, any type. It is asked in the question specifically cosine or sine. Or simply omitting this half range, some question will be find the sine series. Find the sine series of f of x, half range. It will be half range. Or find the cosine series of f of x. And for example, we have a question. Find the half range sine series of. So question in the question paper, find the half range sine series of f of x equal to cos x. Interval is in 0 less than x less than y, half range. Here question is half range sine series. To find the half range sine series. Okay. See the formula. Formula here is for half range expansion. Note that function is defined as 0p. It can be expanded into either cosine series or sine series, called half range expansion. If it is asked to find the cosine series, formula is this: a0 and an are there, bn 0. And formula to find the value is same as that of even and odd functions. a0 is equal to 2 by p into 0 to p. Therefore, integration from 0 to p is only possible because the range domain is only from 0 to p. Therefore, integral from 0 to p is possible here, not from minus p to p is possible here. Okay. Therefore, the formula is a0 is equal to 2 by p into 0 to p f of dx, and an is equal to 2 by p into 0 to p f of is into sine cos n pi by px dx. Okay. P is obtained from this given interval. Okay. If it is asked to find the sine series, then the formula is a0 and an are not there, but bn is there. Sigma n equal to 1 to bn sine n pi by px. Okay, and bn is 2 by p integral 0 to p f of s into sine n pi by px dx. Okay, it's a formula to find the cosine and the sine series. Okay. Next, the problem is like this: find the half range sine series of f of x equal to cos x, and then p is here, p is pi, and asked to find sine series, then we need only find bn. Formula is 2 by p integral 0 to p f of x into sine n pi by p x, and p equal to pi here, it will be 2 by pi integral 0 to pi f of x is cos x into sine n pi by nx. For p, for p we are writing pi and pi cancels, we are getting sine nx dx. Okay, to integrate this, see the notes, we have to have some adjustments. Adjustment is that you consider this 2 cos x sin nx. So this 2 sin nx cos x. you take this 2 to this form, 2 sin nx cos, that is 2 sin a cos b is equal to sin a plus b plus sin a minus b. Using this formula, this is converted into 1 by pi, that is 0 to pi. This 2 sin x, 2 sin nx cos x, 2 sin a cos b. The answer is sin a plus b, sin nx plus x, so it's n plus 1 into x plus sin a minus b, sin nx minus x, sin n minus 1 into x dx. Okay, we integrate this and simplifying, you will get the answer, and that is work out in the note. See the solution. Okay. I am only discussing the method here, and see some other problems also there. Different from this, we may ask to find specifically in the above problem we are asked to find sine or cosine series, but in some problems we are asked to find Fourier series. Fourier series of f of x, but function is half range, this type. Here we are usually in half range problems, this type of half range problems usually asked to find either cosine series or sine series, but here we are asked to find Fourier series. It is not sine or cosine, both sine and cos comes in the answer. Therefore in this case we let it here take 2p such that 2p is equal to this L, this value L is taken for 2p, and p is equal to L by 2. Okay, p is equal to L by 2, and formula in this case is, see, half range Fourier series expansion of f of x defined on 0 to L. It is different from the half range expansions discussed earlier. In the earlier discussion, 0 to p, that is half range, but specifically asked to find cosine or sine series, but here is asked to find Fourier series. Therefore that series includes both cos and sine. Therefore formula is different. Therefore here we have an adjustment. This L is taken to be 2p, so that p is L by 2, and formula is same as earlier discussed, 0 by 2 plus sigma is same formula, but to find the coefficients A0 we have 1 by p into, earlier we have minus p to p, here no minus p, here starts from 0 only, so we have to take 0 to 2p. Here the difference is that 0 to p is already we have in the formula we are taking 2 by p into integral 0 to, but it is different, 1 by p in integral 0 to 2p. Okay, this n also 1 by p in integral 0 to 2p, bn is also 1 by p in integral 0 to 2p. Okay, and 2p is this value, okay, L here. Okay, and one problem is here, f of x equal to x square, 0 less than x less than in a Fourier series. Question is to note it as a cosine series. This is half range, that we know, given it is 0 to L, it is half range, but it is not specifically saying to find sine or cosine series, but asked to find Fourier series. Therefore that series must include both cosine and sine. Therefore we need A0, An and Bn. For this case we take 2p is equal to L, so that p is equal to L by 2, and 1 by p is 2 by L. Okay, and formula is same, 1 by p integral 0 to p f of dx, that is 2 by L integral 0 to L f of x square dx, and simplifying we are getting 2 by 3 L square, and n is equal to also 1 by p integral 0 to p f of x into cos n pi by p x dx, that is 1 by p is 2 by L integral 0 to 2p is L x square function f of x cos n pi by p, p is L by 2, over 2 comes numerator, 2n pi by L x dx. Okay, and simplifying, finding the integral using this formula. Integration by parts are using the first function x square and second function second function is cos 2n pi by l as second function x. First function x square and second function cos 2n pi by lx. Okay. First function integral of second minus integral of derivative of first, that is x square, derivative 2x, integral of second, and simplifying. You see each step and all the steps are written. Answer is n square by n square by. Similarly, we find bn, that is equal to, answer is, for bn's answer is minus n square n by n pi. Formula f is s0 by 2, same formula, but method to find s0, a and bn are different. Giving values, we are getting Fourier series. Here the problem is given half range but not sine or cosine series. Asked to find Fourier series, therefore we have to find a0, an and bn. If it is asked to find for the half range either cosine series, then we need to find a0 and an only. If it is asked to find sine series for half range, we need to find bn only. But if it is asked to find Fourier series in the half range, we need to find three values a0, an and bn. Okay, this is up to Fourier series completes, and we have discussed all types of problems that can come in the examination. And the summary here, in this summary, first discussed f is defined in minus pp, and Fourier series is this. Method is this. Fine. If it is defined and we are asked to find even, if it is checked and found even function, then we need find a0 and an only. If it is an odd function, check for odd function, then series is this. And for half range series, these are full range minus p to p. We have half range this. We are asked to find the cosine or sine separate. It is cosine, this is the formula. This sine, this is the formula. And different from this, it is asked to find Fourier series. In that case, we have an adjustment. We take this 2p is equal to L and p is equal to L by 4, 1 by p is equal to 2 by L, and formula is this. Formula is like same as this for the first case. Formula is same as this for the first case, but where to find the coefficients are different. Okay, 1 by p integral 0 to 2p. 0 to 2p. You see the limit 0 to 2p. Okay. This completes Fourier series. Thank you.